presenting our project management principles, which focuses on the proposed construction of a double-story bungalow in Petaling Jaya, Selangor. Construction projects involves multiple stakeholders, strict regulation, and tight constraints on time, cost, and quality. Without effective project management, even small-scale residential developments can face delays, cost overruns, and coordination issues. This project applies project management principles to the proposed construction of a double-story bungalow in Petaling Jaya, demonstrating how structured planning supports successful project delivery in real construction scenarios.
Next, I will begin by introducing our project charter for the proposed construction of a two-story bungalow located in Petaling Jaya, Selangor. This project is commissioned by Puan Laila Mariam binti Putzil, and our team from University Malaya has prepared the charter to outline the key parameters and expectations. The project is scheduled to begin in January 2026 and complete by December 2026 with an estimated budget of RM 850,000 and a 10% tolerance margin. Through efficient planning and local sourcing, we aim to achieve savings of 20,000 to 30,000 ringgit Malaysia. The purpose of this project is to deliver a high-quality, regulation-compliant residential home that meets modern living standards. It also supports the client's long-term goal of establishing a permanent family residence and contributes to Selangor's sustainable housing development. Our objectives are clear: ensure timely completion, maintain quality finishes, comply with local authority approvals, and manage resources efficiently. The scope includes all major construction phases from site preparation and structural works to finishes, MEP services, and final handover. However, post-handover maintenance and future extensions are excluded. This charter sets the foundation for our planning and execution, ensuring alignment between client expectations and project delivery. Okay, next, we're going to look at the risks, constraints, and deliverables. First, the risks. We have identified three major challenges: potential delays in authority approvals, weather disruptions, and resource shortages. This risk could impact our timeline and budget if not managed proactively. To mitigate them, we have built in buffer periods and prioritized early managed engagement with local authorities and suppliers. Next, the constraints. The project is bound by a fixed budget of 850,000 and a strict timeline from January to December 2026. Site access and logistics also pose limitation, especially during peak construction phases. These constraints require careful coordination and resource planning throughout the project lifecycle. Finally, our deliverables. By the end of this project, we aim to produce a fully approved project charter and plan, a detailed work breakdown structure (WBS), a Gantt chart with critical path analysis, a resource sheet with allocation details, and a final report and presentation. This output ensures transparency, accountability, and alignment with both academic and industry standards.
Now I'm going to talk about the project organizational chart and how communication flows within the double-story bungalow project. At the top of the structure is local authorities such as BOMBA. It's mainly to ensure statutory compliance and CCC approvals. Project owner, who provides funding, defines project objective, and approve major decisions such as design changes, budget matters, and final handover. Directly reporting to the owner is project manager, who acts as the central coordination and communication hub of the project. The project manager oversees planning, scheduling, cost control, and ensures that all parties are aligned with the project goals. Supporting the project manager are the key consultants, namely the architect, civil and structural engineer, and quantity surveyor. The architect translates the client requirements into design and manage authority submissions, while the engineer ensures structural safety and technical compliance. The quantity surveyor controls costs, evaluates variation, and certifies payment. Continuous horizontal communication among these consultants is essential to maintain design coordination, technical accuracy, and budget control. On the construction side, the main contractor reports to the project manager and is responsible for site execution, quality, safety, and coordination of subcontractors who carry out specialized trade works. Communication at this level focuses on daily instructions, sequencing, and safety management. Lastly, communication with local authorities by the project manager is to ensure statutory compliance and CCC approvals. Overall, this structured organizational chart ensures clear communication, accountability, and successful project delivery.
This is the structure work breakdown structure for the construction of two-story bungalow house. Firstly, pre-construction and site preparation includes authority submissions, site setting out, and temporary works such as hoarding and utility setup. Secondly, substructure covers excavation, reinforced concrete foundations, and the ground floor slab, which form the structural base of the building. Additionally, superstructure, which is RC frame, involves the construction of ground and first floor columns, beams, and slab, which support the main building structure. After that, masonry and staircase includes external brick walls for 150 mm brickwork with plastering and internal partition walls. Next, roofing system covers steel roof trusses, roof coverings such as aluminum tiles, and rainwater goods like gutters and downpipes.
Then doors and windows in the building interface. We install solid timber doors, aluminium windows and balcony railing, which are the critical elements for access, security, light and ventilation. Next, finishes is the final aesthetic layer. This deliverable includes porcelain finishes, wall plastering, painting, and flooring to create the completed interior look and feel. Then is followed by the MEP services. It is the building vital system. We install all mechanical, electrical, and plumbing services such as water supply, sanitary lines, and electrical wiring to make the space functional and livable. After that, external work is also known as the site completion. This includes the concrete driveway, landscaping, drainage, and boundary security, which finalizing the exterior for both use and appearance. The last one is handover and completion. We conduct final testing and commissioning, perform a last inspection, and deliver all as-built documents to officially complete and hand over the building.
Next, I will continue with the site layout plan for our proposed two-story bungalow project, which is located at the Mukim Sungai Penchala, Petaling Jaya. The site layout plan is essential as it organizes the construction activities within the site boundary to ensure safety, efficiency, and compliance with the local authority requirement. One of the main site constraints is the risk of flash flooding. The site is located in the low-lying area with the flat terrains, which causes slow surface water runoff and increase the risk of water stagnation, especially during the monsoon seasons. Therefore, proper drainage planning is critical to protect the building's foundation and prevent from long-term structural issues. To mitigate this risk, the site layout plan includes improved on-site drainage system, designated surface water flow path, and also temporary drainage during the construction activities. The finished floor level of the building is also raised in accordance with the local authority to mitigate the floods. Another constraint is the limited site accessibility due to narrow surrounding village roads. As a result, material delivery routes, equipment positioning like cranes, and also temporary storage areas are carefully planned within the sites to minimize disruption to the traffic and nearby residents. Existing utilities are also identified and being protected throughout the construction activities. To conclude, the site layout plan is to address key environmental and access constraints through effective planning to ensure the project can be carried out safely, efficiently, and in compliance with the local authority regulations.
I will now present our comparison of project duration based on each team member's Microsoft project schedule as summarized in the table. Firstly, project duration refers to the total time required to complete the construction of the double-story bungalow from site preparation until final handover. As shown in the table, the proposed durations vary significantly, ranging from 222 days to 276 days, reflecting different planning approaches and assumptions. Starting with Puteri, the schedule has the shortest duration of 222 days. The key strength of this plan is its high efficiency achieved through tight task duration and overlapping activities. However, the main weakness is the lack of buffer time, which increases the risk of delay if issues such as bad weather, authority, inspection, or coordination problems occur. This schedule adopts an aggressive fast-track strategy and will only be suitable if site conditions and resources are highly controlled. Next, Chu Choi Zuan's plan, with a duration of 223 days, follows a similar approach but with slightly more realistic task duration. While it remains efficient, it still has limited contingency during the finishing and MEP stages, meaning delays could still impact the overall timeline. This plan can be described as a semi-fast-track strategy with moderate risk. Moving on to Savan Bala, whose schedule has a duration of 228 days, this plan is identified as the best overall and most realistic. The key strength lies in its balanced approach, where activity durations are practical, sequencing is logical, and sufficient buffer time is provided without unnecessarily extending the project. Although slightly longer than the faster schedules, this plan effectively mitigates common site risk while maintaining time efficiency. Muhammad Adam's plan, with a duration of 232 days, takes a more conservative approach. It allows additional time for coordination and quality control, which improve reliability. However, the longer duration may result in increased preliminaries and indirect costs. This schedule prioritizes constructability and risk reduction over speed. Lastly, Lai Chen-Lin's schedule has the longest duration of 276 days. While this plan offers strong contingency and is highly resilient to unforeseen delays, it is considered inefficient for a standard double-story bungalow project. The extended timeline could significantly increase project costs and reduce overall efficiency. In conclusion, based on the comparison, Savan Bala's 228-day schedule is considered the most realistic and achievable project duration. It strikes the best balance between efficiency, risk management, and practical construction constraints, making it the most suitable timeline for this project.
Next, for the sequence part, all members follow the same sequence because every members develop their program based on the same work breakdown structure, which also known as WBS. The sequence begins with pre-construction and site preparation, followed by substructural works such as excavation and foundations. Once the base of the building is completed, construction proceeds to the reinforced concrete superstructure and then the masonry works and staircases. After the main structure is completed, roofing works are carried out to achieve a watertight building. This allows doors and windows to be installed, enabling internal works to proceed safely. Finishes and MEP services are then carried out in a coordinated manner to avoid clashes, followed by external work such as drainage and landscaping. Finally, the project concludes with handover and completion. This is because the WBS already defines the scope, activity hierarchy, and the logical order of works. All planners apply the same finish to start relationship in Microsoft Project. As a result, there are no differences in sequencing across the schedules. This contingency demonstrates a shared understanding of logical and practical construction sequencing among all planners.
Now, I will present our evaluation of the critical paths developed by each group member. The critical path represents the longest sequence of dependent tasks that determines the total project duration. It's essential for identifying which activities directly impact the completion date. We compared 5 project plans. Puteri Ainin's schedule is the fastest at 222 days, but her durations for structural works are unrealistic short, and her resource allocation is overly dependent on general workers. Adam's plan is more realistic with detailed trade assignments and proper sequencing, but it's slightly conservative at 232 days and includes overlapping phases that could cause coordination issues. Chen-Lin's plan is the most detailed with through finishes and a long handover phase. However, at 276 days, it's the longest and least efficient. Sarvin's plan is well balanced at 228 days with practical durations and a clear resource bundles through slightly longer than Choi Xuan's. Choi Xuan's plan stands out as the most realistic and achievable. It balances efficiency and practicality with a 23 days timeline, efficient superstructure execution, and a practical 9-day handover. Her durations are realistic and the sequencing is logical, making her critical path the strongest and candidate for adoption.
Next, I will discuss about the resource planning for our two-story bungalow building projects. So, a resource planning is an essential part of a project management because it ensures that labor, material, and also equipment are allocated efficiently to achieve the project objective within the approved time and budget. For example, for our project, the resources are systematically identified and categorized into three main categories, for example, like labor resources, material resources, and also equipment resources. So as for the labor resources, it includes the management staff like project manager and also quantity surveyor QS, and also we have the technical staff, which is the site engineer and also consultants, and we have also site labor like general worker and also skilled worker. So skilled workers such as the carpenters, plumbers, barbender, masons, and also tailors, electricians are allocated to ensure according to the construction sequence to ensure productivity and quality workmanship. So the proper scheduling of labor helps to prevent overcrowding on sites and minimize the idle times. So next is about the material resources. They are grouped into work packages such as the substructure, superstructure, roofing works, finishes, and also MEP services, and also external works. For example, it also includes the reinforced concrete (RC), steel reinforcement bar (rebar), roof trusses, doors and windows, and also finishing material like painting and also MEP component. So by bundling the materials according to the work stages, the material delivery can be coordinated with the site progress, reducing the storage issues and the material wastage. Next is the equipment resources like excavators, concrete pumps, and also testing instruments are allocated only when required for specific activities such as the excavations, concreting, and also commissioning tests. So this approach helps us to control costs and avoid any unnecessary equipment downtimes. For example, like we have 5 project management schedule. We have project management schedule. We have Sarwans, Nina, Chu, Chenling, and Adam. So the best one that which is work the best with our project, which is the Sarwan's project management schedule, especially for his resources. So in conclusion, the effective resource planning ensures that the right resources are available at the right time and in the right quantity. So this contributes to a smooth site operations, a better cost control, and a successful project completion within the planned schedule.
Now, let's take a look at the cost estimates from each group member and evaluate their strengths and weaknesses. Putri Ainin Anina proposed a total cost of 890,930 ringgit. Her approach is very conservative with high allowances for risks and uncertainties, which reduces the likelihood of cost overruns. However, her estimate is the highest overall, which could indicate possible overestimation and lower cost efficiency. Troishan submitted the lowest cost estimate at 814,965 ringgit. This plan is attractive due to strong cost control and a low initial budget. The downside is that it relies on optimistic assumptions, includes a lower contingency, and therefore carries a higher risk of cost overruns. Adam proposed a total of 849,040 ringgit, which closely aligns with the summary project budget. His estimate shows well-balanced cost allocation. The potential weakness is that, although slightly higher than the lowest estimate, it may be seen as less aggressive in cost saving. Sarvin's total is 837,900 ringgit, representing a moderate and balanced estimate. The distribution is reasonable with practical budgeting assumptions. However, the plan has slightly lower contingency and limited flexibility for variations, and the allowance breakdown is less detailed. Chinlin estimate 842,460 ringgit, which is close to the group average. This approach is balanced with reasonable overall costs. Some cost components, however, are slightly underestimated, with lower allowances for unforeseen costs, exposing the project to moderate risks. As a result, Adam's project plans provides a realistic and achievable budget for a bungalow of this scale. The total estimated cost of 849,040 ringgit closely matches the summary budget, showing high cost accuracy. There is a balanced allocation across all major work components. Next, a 10% contingency has been included for risk management. Additionally, adequate allowances are provided for professional fees and approvals. Overall, it is a practical and realistic plan that minimizes the risks of cost overruns.
After a holistic review, the analysis concludes that Soishan's plan is the most realistic plan. It provides the strongest foundation for a successful project that is on time, on budget, and built to quality standard. It represents the optimal balance across all our evaluation criteria. Here is a breakdown of why this plan stands out. First is the duration. At 223 days, it strikes the perfect balance between efficiency and reliability, avoiding both excessive risk and unnecessary conservatism. Next is the critical path. It was identified as the most realistic and achievable, with logical sequencing and a practical handover period. Next one is resource management. The engineering-centric approach ensures that the clear coordination and mirrors actual Malaysian construction practices. The last one is cost. The budget of 814 and 965 ringgit is both competitive and realistic, adequately funding all key activities without inflation. To summarize, Soishan's plan stand out for this practically, feasibility and balanced approach across all evaluation aspects, making it the most realistic plan.
In conclusion, this project showed how effective planning tools like Microsoft Project help us manage construction timelines clearly and realistically. By comparing different schedules, we learned that overly short plan risk delays, while overly long ones increase costs. The most balanced plan combined logical sequencing, realistic durations, and structured resource allocation. Overall, this assignment strengthened our teamwork, critical thinking, and technical skill valuable foundations for our future careers in construction and quantity surveying. And that's all from us. Thank you very much.